Hi everyone, I'm Guilhem from Boldo. In today's tutorial, I want to present one of the most important concepts in Boldo, the metamodel. If you think about your architecture repository as a building, the metamodel is the structure behind the walls. It's the structural logic that determines what can exist in your architecture and how everything connects. Before diving into the builder itself, let's start with the bigger picture. Here, we're looking at an example architecture structured in layers. At the top, we have business elements such as capabilities and processes. Then we have applications, then data, then infrastructure. This layered view is intentional. It gives clarity and direction. But here's the key idea. This structure is not imposed by Boldo. We designed it ourselves using the Metamodel builder. And that's the philosophy. Your meta model should reflect your organization's maturity. If a company is just starting with architecture, we usually recommend keeping things simple. You don't need 10 asset types. You don't need complex relationships. Often, four core elements are enough to start: business capabilities, processes, applications, and infrastructure. That's it. Clear, actionable, easy to maintain. Then, as the organization grows and the architecture becomes more mature, you progressively introduce new asset types. You might add data objects, AI agents, risks, projects, IT components. The model evolves with the company. You don't start complex, you grow into complexity.
Now let's see where this structure actually lives. We go to Organization Settings and then Metamodel. Here in the Assets tab, we see all the asset types defined in the organization. These are not individual assets like CRM or marketing capability. These are the categories themselves. This is the architectural skeleton. Everything you model later in inventories, views, nested maps, or diagrams is built on top of these definitions. But defining asset types is only half of the story. Architecture is not just about objects, it's about relationships between objects. So we switch to the Relations tab. Here, we define how asset types can connect to one another. For example, business capabilities can be part of other business capabilities. That's what allows us to create multiple levels of hierarchy. Without that relationship, there would be no level 1, 2, or 3 for the capabilities. For instance, processes can serve capabilities, applications can support processes, actors can be responsible for capabilities. Every relationship you define here determines what becomes structurally possible inside your architecture. In other words, the meta model defines the grammar of your repository. It defines what sentences your architecture is allowed to form. Now let's go one step further and create something new. I click on Create Asset Type. This is where the model becomes truly flexible. I'm not choosing from a fixed list. I'm defining a new structural element that will exist everywhere in the repository. Depending on the organization, this could be an AI use case, a customer journey, a product line, or a regulatory requirement. The type of object always depends on what the company actually needs to manage. If you're a bank, regulatory objects are central. If you're an AI-driven company, AI use cases might be critical. If you're customer centric, you might structure everything around journeys. In this example, I'll create a new asset type called regulatory requirement. I define the name, add a short description, choose an icon, and assign a color. This is not just visual styling. I'm defining a new category that will now be part of the architectural backbone. Once I validate, this new asset type becomes available across the platform. Now that the asset type regulatory requirement exists, it's still structurally empty. It needs properties to become operational. I open the Properties tab. First, I create compliance level. I choose the type score with a maximum of 5. Compliance isn't just yes or no, it's a maturity scale. This allows the organization to track progress over time, from low alignment to full compliance. By choosing a score, we make it measurable. I validate. Next, I add audit status. This time I select the type list because here we're defining a governance state, not a maturity level. I define values such as under review, compliant, or non-compliant. Now every requirement will clearly display where it stands in the audit cycle. I validate again. Finally, I add review date as a date field. Regulatory requirements must be revisited regularly. By structuring this as a date, we anchor governance in time and make follow-up systematic. Now, this asset type is no longer abstract. It carries structure, maturity logic, life cycle state, and temporal accountability. Now that our regulatory requirement has properties, it still needs to be connected to the rest of the architecture. So I switched to the Relations tab. A regulatory requirement never exists in isolation. It impacts something, it constrains something, it is owned and implemented somewhere in the organization. First, I create a relation between regulatory requirement and business capability. I name it effects. This allows us to explicitly show which capabilities are impacted by a given regulation. Now, compliance is directly tied to business value streams. Then I create another relation, this time between regulatory requirement and application. I might call it applies to or constraints. This makes the link operational. If a regulation affects a capability, it will ultimately impact one or several applications supporting that capability. Finally, instead of adding an owner as a property, I define a relation with actors, named owns. Governance is relational. A team owns a requirement. This means we can navigate from the team to all requirements they are responsible for. And this is where the architecture becomes expressive. By defining relations, we're not just connecting objects, we're defining how governance, business, and IT interact inside the organization. Now our regulatory requirement is fully integrated into the architectural model. On the right side, the visual graph makes this explicit. We don't just see a list of connections, we see the structure of the connections. To summarize, the meta model defines three things: what types of objects exist, what properties they have, and how they can relate to each other. It determines what you can model, how hierarchy works, how nested maps are structured, and how your architecture evolves over time. And the most important part is flexibility. You can start simple, you can adapt, you can evolve. The meta model grows with your organization's maturity. Once the meta model is well designed, everything else becomes clearer. Inventories make more sense, views become more powerful, diagrams become more meaningful, because structure always drives clarity. Thanks for watching this tutorial. If you'd like to see more deep dives into how Boldo works, feel free to follow us on YouTube and LinkedIn. See you soon.